All right, pre-AP, pre-calculus 11. Let's take a look at radical equations. So that's the last one here, the last topic for the unit. So we're going to take a look at radical equations. So that's our topic. One thing that we need to note about radical equations is, like, let's say we have root x here. Anything that comes out of root x is always going to be bigger than or equal to 0, right? For this one, because I can't have a negative, like a negative number won't come out, right? Whenever I take a square root, it's always going to be positive. So if I had root 9, that's just going to be 3, right? If I had root 25, that's going to be 5. There's nothing that's going to come out of there that's going to be a negative number. So um, my values under that root always have to be greater than 0, because if I have a negative 2, nothing works out of there, nothing will come out, right? So for a radical equation, this part, the x part, x has to be greater than or equal to 0. Well, this is going to lead to the next thing here, that if I have the root of x plus 2, this part here, x plus 2, all together has to be greater than 0, right? So x plus 2 has to be greater than or equal to 0. I can change the inequality, minus 2 minus 2. I can subtract it, and I'll get x is greater than or equal to negative 2. So what that means on the number line is that I can start at negative 2 and 0, and then I can take any value from negative 2, and that's fine under the radical. If I had negative 3, well, negative 3 plus 2 is negative 1, so I can't do that, right? So I always have to have something that makes what's under the radical bigger than, has to be greater than 0 under the radical. And my values under the radical are always going to be 0 out of it as well, too. So for example 1, right, when we're looking at example 1, it says determine the restriction on. So the restriction is basically what variables am I allowed to use here. So restriction means allowed values for a variable. Allowed values for a variable, meaning that the restrictions are the non-allowed values, right? So when let's make that clearer. Because I want to find out what is allowed, oftentimes it's easier to find out what isn't allowed first. So when we talk about a restriction, it's non-allowed values for a variable, and often they come up because of functions like things like 1 over x. Well, it can't be 0 here. That's x can't be equal to 0. If I have root of x minus 3, well, then x has to be greater than or equal to 3. If I have 2, then I get negative 1 underneath. So let's find the restrictions. Let's find the restrictions for the following. So the restrictions for the following, I have the root of 2x minus 3 equals x minus 3, like that. We'll do that. And what I need to know is that I need that to be greater than 0. So this needs to be greater than 0. So I'll have 2x minus 3 has to be greater than or equal to 0. And I can just algebraically solve for this. This will be plus 3. And then I'll get 2x has to be greater than or equal to 3. And then finally, I'm going to get 2x. I can divide each side by 2. And to get any values here, divide by 2. X has to be greater than or equal to 3 halves. So any x value I have here has to be greater than or equal to 3 halves. Realistically, this here can never be negative, right? So what that means is that this part here coming out of the radical, x minus 3, has to be bigger than or equal to 0 as well, too, because I'll never get a negative number coming out of the radical. So my other restriction is going to be, let's put that in black. So I'm going to have x minus 3 has to be bigger than or equal to 0 as well, because a square root will never create a negative number. So I'm going to add 3 to both sides. add 3 to both sides. So my real restriction here is x has to be greater than or equal to 3, right? Because anytime anything that I have under the square root is always going to be greater than or equal to 0. But if I had 0, right, that would be negative 3 on this side. If x was equal to 0, I get negative 3 there. Let's do another case. Let's do an example case of x equals 2. And I'll show my point here. If we try 2, and I'll show exactly here, that's nice. So we're going to try x equals 2 to make my point. Put 2 here, 3 here, and we're going to put 2 minus 3 there. And what I'm going to get is 4 minus 3 root, and I'm going to get 2 minus 3 here, and I'm going to get the root of 1, and that's negative 1. Well, that's not true. The root of 1 is 1, right? We're not taking absolute values here. We're always looking for it to be specific. The root of, note, negative root 1 can be equal to negative 1, but the root of 1 is not negative 1, okay? We only do plus or minus if we're solving with a variable, not if we're solving for a specific value. So it's only if we're solving with a variable. Like we can get x squared equals 9. The root of x squared equals the root of 9. And if we have a variable, then we can do plus or minus 3. But here we don't have a variable, so we can't. We get a contradiction, right? So we have a contradiction here. 1, and this should be, this does not, they are not equal. So not equal. So everything still has to be greater than 3 for it to work. Okay, so it has to be greater than 3 for it to work. Okay. Let's see now. Okay. Well, and it will guarantee it as well too. We'll talk about that. Some more ideas will come up with that. Okay. Example 2. Okay, so we want another restriction. So we're going to do 3x plus 4 minus 2x minus 4 square root equals 2. Well, we do know that each of these has to be greater than 0, so 3x plus 4 has to be greater than or equal to 0. When I do the math here, this is going to be x has to be greater than or equal to negative 4 over 3. Negative 4 over 3. And this one is going to be 2x minus 4 has to be greater than or equal to 0. So x has to be greater than or equal to 2. Okay, well, which one is the more restrictive? Let's take a look on the number line. So if we take a number line here, let's put that as 0. And here, 4 over 3, let's say this is 1 or negative 1. This will be negative 4 over 3, a third that way since this will be negative 2. And we'll put 1, 2, 3, 4, 5, 6. This will be 2. That'll be 1. So my values can start here and go that way and go here and go that way. Well, this is and, right? Both conditions need to be true. So the only condition that I need to write is x has to be greater than or equal to 2, because that's the one that guarantees both, right? So I'm looking where there's overlap, right? This is the overlap portion right here. So from that point onward, there's overlap. We're looking for overlap on our restriction where I'm allowed to use both x values. And that's kind of what was happening in the original there, in the original question as well too. All right, let's keep rolling along. So let's do one last restriction and then we'll move on to a different type of question here. So that's 3. So I'm going to have the root of 1 minus x, the root of 1 minus x plus root x plus 3, and that's equal to 4. Okay, so let's find our restrictions here. I know 1 minus x has to be greater than or equal to 0 in order for values to be allowed. What I'm going to do is I can do two things. I can do 1 has to be greater than or equal to x, or that means that x has to be less than or equal to 1. Right, we can change it as long as the arrows, as long as the point is still pointing towards the right thing, we can change the order to make it easier to read for ourselves. What it looks like algebraically is like you could do or. If you have 1 minus x greater than or equal to 0, we could subtract 1 from each side and we'll get negative x has to be greater than or equal to negative 1. And because when we divide by a negative 1, we change the direction of the inequality, right? When we divide by a negative 1, or by a negative on an inequality, we change the direction, because it's like saying you're pointing in a different direction when you go negative, right? So like think about it as a thermometer for negative numbers, or when you add a negative number, right? Like a negative, or sorry, if you subtract a negative number, you get positive. So it flips the direction of that as well too. And then we also have x plus 3. X plus 3 has to be greater than or equal to 0. Well, that means for us, x has to be greater than or equal to negative 3. So that's one of our solutions here. Let's see what that means on the number line, because we need to make sense of this. So this is at 0. Let's call this 1, 2, 3. This is going to be negative 1, negative 2, negative 3. Okay, so I know x has to be, and let's shade this one in yellow, and we're going to shade this one in blue. I know x has to be greater than negative 3, so that one goes this way, like that. And we're going to shade it like that. So that's that line. But then I also know that x has to be less than negative 1, less than positive 1. So x has to be less than positive 1. And the shading goes here. But the only place where I have significant overlap is happening between 1 and negative 3. So for this, I only care, only the overlap matters. Only overlap here, right? If I have several restrictions, I can only use the overlapping restrictions here. And we get a better idea of this later as we go on. We call this domain. But for now, we're going to kind of like consider overlapping things on the number line, what's allowed, what's not allowed. So when we look at this overlap, we're going to consider this as x has to be less than or equal to 1, but it has to be greater than or equal to negative 3. And what this means is that here x has to be bigger than negative 3. So this here, this portion right there, guarantees that x is bigger than or equal to negative 3, right? The arrow, the point, still points towards negative 3, and here the point still points to the x, right? So we've kept everything here, and this captures the overlap. You could also think of it as an interval, where it goes between the interval negative 3 and 1, and it includes both of those values. Right, so that's restrictions. We'll do the next one as well. Let's look at solving radical equations. So we'll do a couple examples there as well too. Good.